Chapter 3. We're going to talk about introduction to graphing. Uh, they'll start with how do we get information off graphs and how do you read these things. There's some typical things that we use and strategies to gather information or display information graphically through a lot of different ways. So they're going to start with looking at some graphs and how we pull information from that. And then we're going to start honing in on some ways to communicate using this graphing tool. Like when we use the number line, there's some set rules. We don't talk about that much because we've been probably seen and used number lines since grade school. But we're going to get a little more technical when we get into something that's called a linear equation, and so we're going to set up some rules on communicating. So when we draw a picture or something, everybody hopefully will pull out the same information from that graph. So we have 7 sections here. We'll go through all these kinds of things. We're going to read, we're going to talk about plotting points and some rules around that and how we do that, and scaling graphs. Then we're going to get into something called linear equations. There are equations that have solutions that when you plot all the solutions to it, it ends up forming a line. And then we get into a lot of different ways on how to deal with these types of equations by graphing them to get solutions, and intercepts are just intersections of our coordinate plane axes. So, and then rates or fractions, or a comparison of two numbers, usually kind of relates to slope, which is also a fraction that we'll talk about, a special fraction. And then we're going to use that slope and intercept stuff to help graph. And then we're going to take parts of the information we can pull, like a graph and a slope and those kinds of things, and be able to create an equation from the actual picture of it, and so on. A little stuff about computer programming and using some of this stuff. So, well, here we go. Let's start with reading graphs, and then we're going to get into plotting points and scaling graphs. So they talk about use of graphs and those kinds of things. This is a nice bar graph. It's called, they're talking about weekly earnings or weekly amount of money somebody makes, so they stacked up dollar bills here to try to illustrate that. There's things you need to note about this, and they usually have parts of this. There's a source, there's a vertical scale and a horizontal thing going on here, so we need to look at the labels and what does it mean. And they also tell us something. The bar graph below shows median weekly earnings for a full-time wage and salary workers age 25 and older. And then these are based on how much education they have, and then this is the dollar amount per week that they would earn for the data that they gathered. Median means the middle amount. So that means if I have this $400 a week for less than a high school diploma, that means that $400 a week is kind of in the middle of all the different salaries of data that they got from people that were over age 25 or older that had less than a high school degree. So, good information. We can pull a lot of information off here. It's a good visual, to show that, the more education you get, the more money per week you'll make, those kinds of things. And then they're going to ask some questions there. It says, Kagan plans to earn an associate's degree. What is the median income for a worker with that level of education? Well, here is the associate's degree. So I can look at that, and it looks like it comes very close to, that's why they put that dotted line in here, so I can trace it back to this vertical scale here to about $800. And then they ask if Isabella would like to make $1,000 per week. at what level education should she pursue. So before we found associates right here, I went up this to find out how I can trace it back to the vertical. So I found my horizontal for the associates, trace it back to the vertical. Well, in this case, they want to know if she's going to wants to make $1,000 a week, what level of education should she pursue? Well, then I'm going to go up the vertical scale here to 1,000, come across here, and it looks like at a bachelor's degree you'll get $1,000. And to think about kind of like what we've been with inequalities too. If I asked, I said, well, what uh, level of education should you pursue if you want to make $900 a week? Well, I'd go through here. I need to understand that scale. Well, 900 is right between this 800 and 1,000. Now, what would be the answer to this? Well, if I make a bachelor's, it shows I'm going to be making more than 900. But if I get an associate's degree, I'm only going to make that $800 a week. So based on how I asked that question, you would really have to go up to the next education level to say I'm going to make at least $1,000 a week. So if this is really under this, and they might answer it this week, if they judged by this graph that this $1,000 is not, it didn't reach $1,000, you'd have to get the master's degree level to answer this at least. But I think based on this, it hits 1,000, which includes that. So that's how they explain this part here with the associate's degree, and so on for A. And then in B, it says moving up the vertical scale, we find 1,000, and we move over and we hit that bachelor's degree, at least that, and you could go higher. This next graph is more of a point graph, and they kind of connect the dots to look for patterns. And a lot of times they try to interpolate some stuff. There's a couple things we need to note about this, and this is very easy to miss. It's very easy to be deceptive with graphs too, and that's not their intent here. But notice that I go from here to here is 50, and then I go up by 10, up by 10, up by 10. If you didn't pay attention to that little squiggle line there, you would have kind of assumed that this is the same scale from here to here is 10. And you're going like, wow, this really gets low fast, or whatever way you're looking at that. But the reason they do it in this case is that there are no pulse rates below 50, so they just say we don't need to be really concerned about this area below 50. So they kind of just scrunch that part of the graph down so we can fit it into a better visual, really. Because if I had all these incremented down here, this horizontal bar would be down here probably on that B line with this thing way up here on the top. And that's what they're saying here in the red. So they want you to note that. You need to look for this little squiggled line here, that lightning bolt kind of thing that basically says, hey, we messed with the scale here. So what information can I get out of this? Here I have the explanation of the vertical scale. Here is resting pulse rate, which is the number of beats per minute. So I started out here, it looks like it was around 90, 95, maybe 90, not 95, excuse me, like 91 or 92 at resting rate. And then here is a timeline, really. This is a number of months of regular exercise. So at the beginning of this data collection, we started with a person who wasn't doing any regular exercise. This was their resting pulse rate. After a month of regular exercise, this is the new pulse rate, and so on. And then they're going to ask the question, how many months of regular exercise are required to lower the pulse rate as much as possible? Well, in this case here, it comes down. Here's the lowest point, and then it starts to come back up. So based on this question, how many months of regular exercise are required to lower the pulse rate as much as possible? So I'd look at this thing and say, well, what is the lowest pulse rate? And it looks like it's right here. Well, we reached that lowest point after 6 months. And then it says how many months of regular exercise are needed to achieve a pulse rate of 65. So then I would find the 60, between the 60 and 70, it looks like here is someplace right around in this arena here. Maybe it's not right at 3 months, but as they're collecting data, maybe it was like 2 months and 3 weeks. It hit that 65 right on or very close to it. And that's how we'd answer that question. Now I like when they put this in here because we're going to talk about movement in a vertical and horizontal movement that occurs to go from one point, kind of like I'm starting at 0 and I want to get to this point. We're going to talk about how you'd travel, which is going to set up some relationship stuff on how we set up ordered pairs and points. So we need rules if we're going to have these axes. So what really the axes here are number lines. When we only had one dimension, when we only have one variable or one thing that we're looking for, or one thing that we want to draw a picture of, we just had a number line, and that's usually called the x-axis here. The first axis is horizontal right here. Now to have a second point illustrated, or two-dimensional, we have two dimensions that we're talking about here. I have a horizontal dimension. If that's all I wanted, I'm just putting points on a number line. But if I have a horizontal dimension and a vertical dimension, I end up with this plane right here called a coordinate plane. And now I don't want to miss any key words here. So we have graph or plot. Basically, we're going to put points on this diagram. And we have these axes and single axis, where they cross at the origin, or in other words, this number line right here is 0, and on this vertical number line, that's where 0 is too. So that crossing of those axes is the origin, or later on we'll talk about it's a point called 0, 0. Now consider the pair 3, 4, and in here in the red, and they're going to be talking about this point. Well, these numbers are in such a pair, they're called coordinates. The first coordinate in this case is 3, and the second coordinate is 4. And to plot this, we graph 3, 4, we start at the origin, and this is a very good way to look at this, is I move horizontally 3, and then move up vertically 4 units. In other words, I start here at the origin, I move to the right 3, that's a positive direction horizontally, and what is a positive direction vertically would be up 4, and I'd end up at this ordered pair of 3, 4. Now it's pretty important that the order really matters, doesn't it? If in this case I said, it's first is the number is the horizontal change from the origin, and the second number is a vertical change. So there's a big difference between the ordered pair 3, 4, which we haven't talked about what ordered pairs are, but I will talk about in a second, and this one. And that's what they're really trying to illustrate, is that order matters. So when I have these pairs in this way, it kind of looks like interval notation when we were talking about inequalities. One of the problems that I have with interval notation is it looks very much like this. But in this case, we're talking about a coordinate plane where we have a y or a horizontal axis and a vertical axis. Well, to plot points, we need to define or basically keep things in order. So when I put these numbers together with parentheses around there, we all end up plotting that in the same place. So the first number is change horizontally, and the second number is change vertically. So in this example here, to plot the point -3, 4, mean I'd start at 0, I'd move to the left 3, that's a negative direction. I end up 3 units to the left. And then the second number tells me to go a positive 4, which is up 4, and I end up over here in this quadrant. Okay? I don't know if we missed the quadrant thing. Okay? So graphing is not a difficult thing other than we need to know the order, or we're going to have some problems illustrating that point or that location on that graph correctly. So they're going to give us some questions like this. We've got all these points. A lot of times they label points with capital letters. So this question is, well, what's the ordered pair of all these? So like point A, if that's the first one, I would go, how far did I go horizontally? Well, I went from 0 to right here to 4, so the first coordinate is 4. And then I went up 3, so that's positive. And so the next one would be a positive 3. So I would say point A is 4 units to the right, 3 units above. So the coordinates of point A are 4, 3. Now they tell us the coordinates for each one of these, and then you'd fill that in. Now variables x and y are commonly used when graphing on a plane. A plane is not like an airplane, though that's what it's really named off of. You have those big wings that create a plane or a flat surface, two-dimensional surface. And so that's what they're talking about, that plane that's created that. Well, we have basically not always, but the way to remember this is we tend to think that the first number in my ordered pair is the x coordinate and the second is a y coordinate. Well, that's almost always true. We tend to have patterns that we try to follow in algebra and those kinds of things, but what is really true, the definition of an ordered pair, is the first number in that ordered pair means horizontal change, means movement left or right on a horizon or a horizontal line. And the second one is vertical change, up and down change. So even if it was an x, y, if I didn't, so we have in this case the horizontal axis is x, so things on here would be things we talk about being the x coordinate. And this, they say this line is called y, this axis is y, so that vertical change is ticked off here on this vertical axis, right? So this coordinate would be associated with that, y. Now they do some things with quadrants, and really the way they name this is basically the first quadrant right here is the most graphing that we look at. They work almost always exclusively in this quadrant. When we're talking about like that salary stuff, all that stuff is amount of education and how much salary. It all ends up in this quadrant when I graph. That's why they say that that's number 1. They use a Roman numeral 1. And then the next, probably most common used one is to stay on this horizon, really, and we work maybe on these two sides. So this is the second quadrant, and then they just go around counterclockwise. So here's third quadrant, fourth quadrant. And there's patterns to this. If you think about everything for this to be in this quadrant of this coordinate plane, both coordinates have to be positive. I have to go a positive direction horizontally, and I have to go a positive direction vertically. Well, when I have a positive number and a positive number, that tells me that I'm in quadrant 1. Now, I don't think it's that big a deal to have to memorize this. If you are in a testing situation and stuff, other than you need to know the quadrants, I don't know if I would have to remember that I have positive, positive, and then in this case the horizontal is negative and the vertical is positive, so you get negative, positive. That's what they're showing us. And here they're both negative. I go to negative horizontal, negative vertical, and those kind of things. They say, hey, negative, negative, and then down here is positive, negative. Well, I think if you can draw this picture, remember that you go 1, 2, 3, 4. I think you have all those patterns. You could figure it out just by plotting some points if you forget these patterns. But this is a nice shortcut to say, hey, I look at an ordered pair, I get a visual, I should know pretty quickly where it's going to sit on my coordinate plane. Just get a mental image of that. This next part is about numbering the axes appropriately. So we're going to talk about scale a little bit, and it's kind of like that squiggly line where they change the scale and those kinds of things. Well, they show us here if we had graphing calculators. We're not using these in this class yet. But they talk about Windows views, so you can actually change the scale to make it fit or work within the information it's going to graph, which could be pretty important, especially on a computer device like that. You could graph something, and if your scale's not right, it might look like it's blank, but it basically was drawing something way over here off screen. So let's look at example 5. It says use grid 10 squares wide and 10 squares high to plot negative 34, 450. Now what does that mean, that grid? Well, here's my horizontal axis. They said I'm going to use this 10 wide. That means from here to here. My ticks on this go from 0 to 10. Now the vertical, they also want it to be ticking off at 10 and do those kinds of things. And let's look at that result here. And what you'd have to do is this 450, and that's what they're trying to illustrate, is way up here or way away from here. If I went by ticks, I'd have to go 40, 45 ticks, 45 tens up to get to this negative 34. I'd go back 34 about here. Then to get to 450, I have to go up 10 ticks, and if it was scaled the same way, that's going to be off my screen there. So they're talking about maybe we can scale this to fit better, and they say, well, wouldn't it be better if we took this vertical scale, because there's such a wide range of vertical numbers, that second number in the coordinate plane, that we could possibly say, well, why don't we say one tick here is 70 instead of being 10, which is going to be very, very high and very, very low. We're really going to spread out on my graph paper. So we can take advantage when we know the ordered pairs that are going to be there to say, let's scale this so we can get it on the paper in a sense, and hopefully scale in a way that you're going to do that. And that's really what they're pointing out, is you're going to have to kind of look at your data, your ordered pairs here, and get an idea where they're going to end up again, and what quadrants and those kinds of things, and how far away from the origin. And maybe I can change scale to make that a little easier to draw a picture of it. So that's pretty much it, just to start the graphing, and then we're going to jump right into linear stuff. We're going to get into some more rules, and then we'll get back to the algebra side of that to solve equations to work with it.